This is the project document of the semester. Q-tire network, 3 floors with 3 routers. You all get a separate address space. And here, for example, for dynamic routing protocol, some of you are gonna do it with RIP version 2, OSPF, or EIGRP. So let's see the main topology. There are 3 floors, and in each floor there are some not LANs, there are VLANs. This is a topic you need to research for the project. So first floor, second floor, third floor. So here we have 3 floors, 3 routers. As you see here, routers should be connected to each other using fiber optic cables. Let me just give you this quick examples. I prepared 3 routers here. I'll just use some kind of fiber cables to connect them each other. Here, there's fiber here to fiber, fiber to fiber, and the last one, fiber to fiber. So this is clear. We have 3 routers similar to this topology, or not necessarily similar, it's up to you, but this is one of the possible topologies. Now each floor will be connected to its own VLANs. You will use 1 or 3 switches, but let us explain one important topic here. You will have to use VLANs, not LANs. So for example, in the first floor, you have VLAN 10, you have VLAN 20, and you have VLAN 30. The names are logistics, store, and reception. VLANs are a way to split one switch into multiple switches or virtual switches. This is something that you need to search. For example, if you have here one switch, here, usually you have so many ports in the switch, and all the switch ports belong to one subnet or one LAN. But with VLANs, you can change this. You can, for example, make these switches ports belong to VLAN 10 only. So only devices from VLAN 10 can access it. You can, for example, here, if you have ports, 3 ports here, you can make them, for example, for VLAN 20, and you can have any other VLANs. So it's a kind of virtually splitting the switch. Instead of having multiple switches with separate network connections and router connections, you can define the ports to belong to certain VLANs. This is something you need to search. For example, if you see here in the first floor, you're going to have reception VLAN, number of hosts 300, store VLAN, number of hosts is 200. Of course, in the submitted topology, we just use samples like 1 switch and 2 PCs for each VLAN. So the VLANs here in first floor, second floor, and third floor. So you need to do this by splitting the ports to certain VLANs. Then how to connect the VLANs to, or the switch to the router, this is another story. It depends on which way you select. For example, this is a switch here. Let us say we have separate VLANs by color here, as you see, color-coded VLANs. So you can either connect each VLAN to the router. Let us say this is our router here. You make one connection from VLAN to the router. This is easy also to configure, but needs a lot of ports here. We call this access. Or the other way is to connect the router to the switch with one port, but this needs some configuration, and this is called trunk. This way, you still can have VLANs connected with one cable. We call it router on a stick, but it needs some kind of some kind of configuration here. Whichever way, access or trunk. Access, which is each VLAN connected to the router like this, or trunk, which is one connection, is acceptable. This one is easier, less ports, but it needs more configuration. And the access one here from each VLAN port to the router is simpler to configure like this one, but needs a lot of ports. So for the VLANs, we give you this information, and the remaining part is your research. Go back to that topic here. Okay, RIP version 2, for example, here, you might have OSPF or EIGBRF or EIGRP. So let's see what we have here. We need to configure dynamic routing protocol, and the second point here, we say configure static routes on each router as a backup for dynamic routes. So let's explain this. If you have routers, what we did usually with routers like this, if you have routers like this, for example, 1 or 2 or 3 routers, we usually in the lab, we did some kind of static routing between routers to explain all networks. So we give static routing for this LAN and static route for this LAN on this router. We did the same on this router for the LANs here and the subnets here. In the project, we will not use static routing as main routing protocol. There are routing protocols that are dynamic. Configuring them is very easy. For example, RIP version 2 or OSPF or EIGRB, whichever you are required to do, are easier to configure. They don't need you to distribute and mention all subnets. They do this dynamically. They keep updating neighbors with their routes. However, sometimes those dynamic routing protocols fail. They stop working for whatever reason. In addition to the dynamic routing protocol you configure, you need to configure static routes. Type, how come we need both static route and dynamic routing? Let's tell you this. The default protocol will be the dynamic routing. This is going to be the default protocol, dynamic. However, if it fails, the static route should be activated. This is usually done by giving priorities. If you give lower priority, for example, or administrative distance to the static route, it becomes a backup, not the default route. So you give it very low priority or administrative distance, and in that case, it becomes as a backup protocol, and it works only or gets activated only if the dynamic routing protocol is activated. So you need to configure your network topology with dynamic routing protocols between the routers, but in each router you need to go and give some kind of static routes. And those static routes, when you give them, they can be given separate priorities or very low priorities, which make them backup routes, not main or default routes. Next step, all devices automatically. You have DHCP servers. Now, you studied in the lab how to configure a device, a real computer, as a DHCP server. For example, this one is a server. You go and give it IP address like this, and then you go to services, DHCP, and you enable DHCP, and you start giving what DHCP, the default gateway of the LAN, and. This is fine. However, what you don't know, or maybe you know, that you can use routers to distribute IP addresses. You can go to this router and configure the router by commands like IB, DHCP pool, whatever commands, okay? You can keep going and do this, and the router in this case will be distributing the IP addresses. So you just need to search how to configure the router to be our DHCP server. Of course, for each floor, the router will be the server of that floor. For example, for router 2, you go and configure router 2 to be the DHCP server of floor 2. And you provide the addresses according to that. It is very easy, the same concept. And even at your home, if you don't know that, at your home, the wireless router you have from Ooredoo is your DHCP server. So it gives you IP addresses. A server is just a program. It can be put in a separate computer or on the device, like a router. So in this project, you need to configure DHCP server to be on the routers, and you need to configure each router for the LANs or for the subnets or for the VLANs in that floor. Next one. Okay, only SSH needs to be configured or used on all switches. There should be no telnet in this project. So what's the replacement of telnet? SSH. SSH is a secure protocol. It's encrypted between the 2 points. So you need to enable SSH on your topology. It's very easy to enable it, but you need to make sure that you need to know that telnet, of course, is not being used anywhere. It's not allowed, but the concept is the same. The difference between telnet and SSH is that SSH is encrypted. So you need to configure your project, your topology to use SSH. You need to do this search. It takes less than 10 minutes. If you understand it, that's direct, straightforward. Just apply SSH. Now let's say one more thing here. The IT department, one server host. Okay, there will be one device only as a server, physical server in the IT department. Let us say this is the IT department. So in this server, you will enable FTP, you will enable email, you will enable all of them. So actually, you will use only one physical server. This is not common in real life, but here to save space and we need less devices on the topology. This is just a simulation software. So we need just to provide one device and use the same device to be your FTP, HTTP, whatever, and DNS, and that's it. Next, wireless. Another one important thing here, they talk about Wi-Fi network access points. They need to be connected to laptops and phones. Okay, connect the switch to router using gigabit Ethernet port. That's fine. So let us talk about this wireless access. Since we are using VLAN, this needs some kind of attention. Let us say this is our switch here in the LAN. Of course, your switch has so many ports. And in this project, the ports will be separated into multiple VLANs. And you need to use access points to allow, access points, not wireless routers, to allow wireless service. And here, for example, you go to wireless devices. Here, I go to wireless devices. I'll take, for example, any one of those. Let me see. This is wireless router. This is access point here. And if you need, I took access point 2 just as an example. If you need a laptop ready with the wireless card, you go to the miscellaneous. This one, the one you find here, does not come with the access card, with the wireless card, but the one in the miscellaneous comes with a wireless card. And if you go here, you can do configuration. See, now the connection is very fast. You can do configuration on the access point settings to just give it a name like sales. If it's a sales VLAN, you can go to attributes, whatever, any simple port 0 here, port 1. You can give a name to SSID is the name of the network. Do whatever you want here and make it high. And then you go to the switch and try to configure the BC wireless to connect to the BC. Just go to BC wireless and try to connect to the access point. One important thing now in each floor you have multiple VLANs, sometimes 2 or 3. You need one access point to be connected to one port of that VLAN. Listen again. You need one access point like this now. Let us say this access point is connected to fast Ethernet 01 and this 01 belongs to VLAN 10. I need another access point for devices of VLAN 20. And that access point is going to be connected to one of the ports that were given to. Here I'll just get another access point, whatever here. I will connect this to one of the ports that I have given to, let us say, fast Ethernet 10 belongs to VLAN 20. So in this case here, access point, let us say this is for HR and this one for sales. So the HR access point, which should be connected to a port that has been given to the HR VLAN, and the sales should be connected to the HR or to the sales port or one of the ports. How to configure devices? This is easy. Just go to the device and you see what to do, how to configure it. Is not a big deal here. And here you can go and select what is the SSID. For example, you can say SSID should be sales or HR. It's up to you which one to select to, and it should be activated on both of them, and that's it. See, now it's connected to sales, and they get the IP addresses from the server if there is one server. So you need multiple access points, one for each VLAN port, and then the remaining things is you do it. Let's see here what I missed. If I don't think anything is left. Oh, TFTP. You know FTP service. FTP uses TCP IP, which makes it reliable. There is another simple, very useful, very simple protocol called TFTP, Trivial FTP. You can use to upload and download files quickly. And usually this does not need any authentication, and it's a UDP based one. In your topology, the same server, you're going to configure the same server, this server you're going to configure a TFTP, and you can give it a name on the DNS. What you need to do, all switches and routers on the topology needs to update or upload their config files, startup config, to that server. One more time, you need to use a TFTP server, and in your topology, all devices, switches and routers need to upload their config files, startup config to the TFTP server. It's just one command, copy TFTP, and also you can get from the TFTP server. For IB version 6, straightforward, direct, no subnetting required in this project. Only apply, you are given an address, and only apply it to the devices. Only apply it to the devices. Let's see if we have anything here. I believe I explained what I wanted from today's demo. Actually, today's demo was a miserable failure. There was no screen sharing, there was no voice recording, there was nothing almost. I didn't know that. So now you need to take care of VLANs, SSH, dynamic routing, TFTP, and you need to also learn how to connect access points and wireless devices. Good luck.